This is part one, dev environment setup and common programming concepts. We're going to cover installation, common development environments, and common programming concepts like variables and mutability, data types and functions, comments, and control flow. This is essentially just the first couple of chapters of the Rust book. So installation, I would say as a language, Rust is probably one of the easiest to set up out there. There's really great instructions on the Rustlang website, which tell you how to install it. The main way they recommend doing it, which I would recommend for all of you, is using RustUp. The one kind of slight gotcha or thing that people might sometimes trip up on is the requirement for a linker. Most of you will already have a linker installed, but if you don't, then you'll find that you probably need to install GCC or Clang on Linux, which you can do via the Build Essential package, among other things. On Mac, you might want to install Xcode Select, and on Windows, it'll be the Visual C++ Build Tools 2019 or equivalent. With your Rust installation, generally, I'd say if you're unsure what to install, just follow the defaults. If you're more advanced, it's normally relatively straightforward to figure out if you want a custom kind of setup, but there will be fewer troubleshooting steps online for you. Some background about what RustUp is. So that's what you've used now to install your toolchain. People refer to it as a toolchain multiplexer. So it's similar to PyEnv, and it allows you to have multiple toolchains installed as well as channels. And I just wanted to cover a bit of terminology, which for most of you, you don't need to know it, but for those of you who are interested, you'll hear these terms kind of talked about in the context of Rust installations. You'll hear people talk about channels. So there are 3 channels in Rust: stable, beta, and nightly. And this is the way that Rust keeps up with like a 6-week cadence of delivering new versions, is it has these nightly versions and these beta versions that allow kind of features to get tested and used before they go into stable, at which point they become accessible for everyone. The toolchain is what you install, which is specific to your environment. So if you're running on x86, then you would install stable x86, Windows, MSVC. You can see what toolchain you've installed after you've done the RustUp installation with RustUp toolchain list. As well as having the toolchain, you might have multiple targets. So this is what you use for cross-compilation. So cross-compilation is if I'm building locally for Windows or building locally for Mac, but I want to compile for a different target, like maybe I'm compiling for my Raspberry Pi, or maybe I'm compiling for Android, then you can install a different target so that you can cross-compile, and it's very easy for cross-compilation. Just wanted a question in chat. Will this be shared afterwards? Yes. So we record the meetup so that we can upload it, and you'll be able to catch up after. But just to emphasize, nothing that I'm sharing in this talk is not available elsewhere. So the Rust book, which incidentally you will also get after you install RustUp, will have all of this information in it as well, and in a very similar structure. And then finally, I'm going to talk about components. So RustUp has like a set of recommended components that you will get by default, but there are additional ones that you might want to add. But this, you can do Rust component list to see what there is, but you'll generally get the Rust compiler, the standard library, Clippy, which is like the linter, Rust format, which is what you use to kind of get a standard formatting on your files. You'll find that Rust is a fairly opinionated language, and that means it looks quite similar between different projects, which is quite nice. In terms of development environments, I meant to update this slide and didn't. The most common development environment I would say is VS Code. Loads of people use VS Code. It's very simple to hook up. There's extensions you can use to connect up the linters. But another common one is Rust Rover, which is provided by JetBrains. But you can also just use text editors, so Helix, Vim, and Emacs. Whereas I put Z in text editor, I've never used Z, but apparently it's more on the IDE side. And it's written in Rust, so that might be something you want to try out as well. But if you're trying a new language, maybe stick with an IDE you're familiar with to start with. In terms of tools, so I've kind of already mentioned Clippy. So Clippy is the kind of linter and formatter that gives you really useful information and advice on writing Rust with best practices, avoiding bugs. And later on in the presentation, you'll hear me give examples of Clippy errors. So if you're familiar with C++, I'd say Clippy is kind of similar-ish to Clang Tidy, but also kind of static analysis tools. And it generally protects you from a lot of common bugs and pitfalls in Rust. I would say generally you want your Clippy to be completely clean. Tend to try and avoid warnings and errors wherever possible. The other super common tool is Rust Analyzer. You can get this as a component as well when you do the Rust up install. You can also use the VS Code extension. And you can use that in any editor that supports the language server protocol. So VS Code, Vim, Emacs, Z, etc. All of them support integrating with Rust Analyzer. So you've installed your Rust toolchain. How do you actually build anything or do a hello world in Rust? You can use rustc directly. So you could create a .rs file, which is what we use for Rust code files. And then you can just point rustc at it and it will compile it. It will look at what target you need and it will build it for you. So here's a main function, which just prints hello world, the absolute classic. But what you tend to do is hello cargo. So cargo is a real Swiss Army knife in Rust. You will hear people talk about it all the time. Cargo is your package manager, it's your test runner, and it's also your build tool. So you generally create a new project using cargo with cargo new, and then the name of your project. This will then create you a binary crate. You can change directory into that new hello cargo directory and do cargo run. And it will have created a little hello world file for you in main.rs and it will just run. You'll also notice that you get these additional files. So you get a toml file and a lock file. We'll cover those kind of later in the series, but if you just do cargo new, it'll create all the bits you need without any additional work required. It also initializes it as a Git repo. You can avoid that or use your own version control system if you want, but you can also just use the defaults. Once you've installed Rustup, you get access to what people refer to as the book or the Rust programming language, which is on kind of the closest thing we have to like a specification. You can also access it online. We can drop links in the chat, but hopefully you've all found that. I think it was linked in the Meetup description. And that's what we'll kind of be covering in this 4-part series. I'll cover a bit of chapter 3 here with variables and mutability, data types and functions, comments and control flow. And then later on, we'll get into the more Rust-specific topics like ownership and the borrow checker, which tends to be the one thing people have the most questions about. Yeah, so let's get started. Variables. I'd say variables in Rust look quite similar to other languages. So in Rust, you use let to declare your variable, you then give it a name and then a value on the right-hand side. Compare that to Python, it looks very similar, and C++, if you're using a version that supports auto, then it would also look very similar. It's worth saying that it's got a type, even if you don't see it. And if you've got Rust Analyzer, if you're using VS Code and you've got a linter installed, then there will be a type annotation that you'll be able to see. So in this case, when we've done let apples equals 5, that's actually created an I32, and you'll see it in gray in VS Code, but you can also explicitly add it if you want. So in C or C++, you saw in the previous slide, we had auto. We could have also written there int 32 apples equals 5. But unlike a lot of other languages, it's immutable by default, and this trips a lot of people up when they're working with it for the first time, unless they're coming from a functional programming background. Any Haskell programmers in the house? Yeah, so if I say let apples equals 5 and then I say apples equals 6, I'm going to get an error. And fortunately, the error kind of tells us everything we want to know. So this was, I would say, my biggest learning curve when I switched to Rust, was learning that I should just read the error message, like every word in the error message. I was coming from a background of C++, and the errors could get very long. So I got very used to like skim reading them and looking for common problems. But with the Rust errors, I'd say they're generally pretty good, and it's worth taking the time to read every line. So in this case, it says you cannot assign twice to immutable variable apples. Shows you where the first assignment is, and then it shows you where the second assignment is that wasn't allowed. And then it says, here's a possible fix for you. You could make this binding mutable. So we could follow that example. We could say let mut apples equal 5 and then say apples equal 6. Or if you're coming from a functional background and mutability kind of gives you the ick, then you can instead use shadowing. So you could say let apples equals 5 and then let apples equals 6. So here we're creating a new variable. It doesn't have to be the same type. We're not mutating the previous one, but we're reusing the name. On every line after this, we won't be able to access the first apples variable. We'll only be able to access the new ones because we've shadowed it. It might be tempting to initially, if you're coming from a language where things are mutable by default, to make everything mutable. That is I'd say, an anti-pattern in Rust. Mutability should convey your intent. If you don't intend to mutate something, you shouldn't mark it as mutable. And indeed, if you have Clippy, then you will get an error. In fact, it's not even a Clippy one. I think it's just a compiler warning. Generally, it's good to compile with warnings as errors so that you can't run your program if it has any warnings. So here it tells you this variable does not need to be mutable, so you should remove this mute. And I guess just say if you were modifying it, obviously it wouldn't give you that warning. So those were kind of the basics of variables. We've only used I32 so far, so let's move on to the other data types available to us. Specifically going to start with the simplest ones. These are our scalar types. These are things like integers, so I32, U8, all your classics, I64, and then also your floating point numbers. So generally these are kind of written as like F64, F32, and these are all IEEE notation. If you don't know what IEEE means, don't worry, you don't need to know. But if you are so inclined, then yes, you can look into how it's actually represented under the hood. There's also Boolean, so true or false, and there's the kind of primitive character type, which is denoted with single quotes, which could just be a simple letter like A, or it could be a full emoji, and these are 4-byte Unicode values, which is, yeah, you'll see is not how we tend to represent strings in Rust more generally. Strings are a big pain point in Rust for newcomers sometimes, but the character type is a full 32-bit 4-byte Unicode value. We also have compound types. So in this case, we've created a tuple with 3 values, an I32, an F64, and a U8. If I hadn't put the type declaration here on the left, then this U8 would have actually been an I32 because it would have defaulted to an I32, the type inference there. For arrays, they would all be the same type. We've explicitly said that I32 here, but we could have just as well left that off and it would have figured out what our type was. So these, those type declarations are optional, but they do have an impact if you use them. Okay, whizzing through this fairly fast. So do you want to pause and answer any questions at that point before we move on to functions? I know, Tim, I see you a little answering in the background there. Is there anything that's worth flagging up?
So we did some poll of programming languages. We have a quite diverse background.
Nice.
What come up was like if shadowing is used often in Rust. And yeah, my experience when I give workshops, shadowing is one of those things that are very confusing for people because they're used to have their types tightly coupled to the names and so on. But actually in Rust code bases, you see that quite often that the type of a variable changes, but not as a semantic. But maybe, Kira, what is your take on that?
Yeah, definitely. I mean, I was sufficiently shocked at shadowing. So when I first started learning Rust, when I started organizing this meetup, actually, we did like a swap where there was someone else who programmed in Rust who tried learning C++, and then I tried learning Rust. The biggest shock to me was the shadowing aspect. But actually, I imagined in my head that it was going to be an issue, that it was going to make code more confusing. But actually, I found the opposite was true. Being able to reuse names um, when like types get converted is really, really handy. So I think the example they give in the book is like you get user input as a string, and you say, okay, how old are you? And then you parse it into an a U8 or something. Um, I could have said age underscore str and then said that's the input, and then age underscore int or something as the name for after I've parsed it as U8. Or I could just use the same name and just call it age both times. And because of how strong the type system is in Rust, you don't get the kind of errors that you might think, or you don't get confusion. And because you get warnings if there's unused variables, it means you're unlikely to accidentally shadow something, because if you create a variable but then you don't use it anywhere, it will warn you. So all those commonly associated problems with shadowing just don't seem to really manifest in Rust in my experience, and it just makes your code cleaner and your naming much simpler.
Uh, Hi, I have two questions. Uh, the first one is when we don't have mutability attached to the variable, so like it's immutable, and when we have mutability internally, how does Rust compiler treats it differently? Like for the immutable ones, does it put in some read-only section? Because every variable has to be associated with some kind of memory allocation, which is true for both the cases.
Yeah, so I think that's a really good question. I think that's the nice thing about working in a compiled language is there is no difference between something having been marked as mutable or immutable at runtime, but at compile time, that's when it makes the big difference. So that's how it kind of catches bugs. Um, and it can then do optimizations in the compiled output, because if you know something's not going to change, then you don't need to account for it changing. You can just have it being a constant later. I'm not a compiler expert by any means, but generally that's the reason why you want to declare things as not changing, so that the compiler can make optimizations. In terms of that like mute keyword, it's not doing anything beyond telling the compiler like you know this isn't going to change. If that makes sense. Um,
Yes, and the second one is shadowing when we do, like, so suppose we have a variable one and then we shadow it, maybe as you said, like we change the type of it. Uh, so what happens to the like the variable that we were shadowing to? So is it deallocated also? Like how?
That's also a very good question. So it will be deallocated when it goes out of scope, and it doesn't go out of scope when it gets shadowed. It goes out of scope when the scope ends. So that would be like the next closing curly brace. It's only the kind of name you can't access anymore, but the memory is still allocated. Because you're right, it would be crazy if you couldn't predictably see how things were being deallocated in the case of heap allocated types.
Interesting. Yeah. Thanks.
Okay, cool. Let's crack on with the next section, and hopefully it will answer a few more questions as well. So functions, again, I would say these look very similar to what you'll have seen in other languages. You have keyword fn here in Rust, whereas in Python it's def. You have your function name, open brackets, close brackets, and then you have the body of your function. In this case, we're just printing hello world. The differences start to kind of come to light when you bring in parameters and return values. Unlike in our earlier cases where we could infer a lot of the types, here these types must be declared. The return is typically implicit with no semicolon. So here, where we've written x plus 1, that is going to be returned. We've said it's an I32, and the parameter we passed in was also an I32. You can also do explicit returns, so you can see the return is keyword, returning x plus 1, and that line does end in a semicolon. This is less common. You do see it, you do use it, but generally it's worth getting in the habit of doing these kind of implicit returns. And indeed, if you do an explicit return where you could have done an implicit one, it will give you a Clippy warning. So it's this Clippy needless return warning. So there on main.rs, we've got return x plus 1, warning, unneeded return statement. And it links out to Clippy docs. Those will give you additional information. And I would really recommend, especially when you're getting started with Rust, when you see a Clippy error, before you do the fix, if you don't understand why it's asking you to do the fix, visit that link, read the information there. A lot of it is really well crafted and really well written and might provide additional context that will help you avoid those pitfalls in the future. If I was doing an early return, then I absolutely would need to do explicit return. So in this case, I've said this is the function that maybe adds 1, checks the value on the condition that it's 42, it returns x plus 1, and then if not, it returns 12. In that case, if I didn't have that early return statement, then the function would do something different. So it wouldn't make sense. And cargo Clippy won't warn here. This early return is totally reasonable. Whereas if on that last line I'd written return 12 semicolon, that would have produced a Clippy warning. This bit is a little bit subtle. Talked a little bit about the kind of like implicit return types, and when you're thinking about like what code is reasonable to write and what isn't, it's worth in Rust thinking about the concept of statements and expressions. So statements do not return values and therefore they cannot be assigned, whereas expressions do return values and can be assigned. That can seem a little bit confusing at first, but it becomes really helpful as a concept to get into your head when you're trying to figure out why the code you've written doesn't work or doesn't compile. So in this case, I've written let apples equal 5 plus 5, semicolon. 5 plus 5 on its own is an expression, whereas that whole line that ends in the semicolon is a let statement, which means I couldn't write, for example, let apples equal let pears equal 5 plus 5, because that let pears equal 5 plus 5 is a statement and doesn't return anything. So I can't then assign it to apples in this case, and it will give me an error. And the error will look something like this. Expected expression found let statement. So where I've got let apples equal, it expects whatever's on the right-hand side to be an expression. Instead, it found the statement let pears equal 5 plus 5, and that's why it errored. Function calls always are an expression, even if they return nothing. And this is, again, kind of an interesting concept to think about in Rust, because there's this idea of the unit type. So if I've got a function hello world and it doesn't return anything because it prints hello world and then does nothing else, I can still write let y equal hello world. And that's because hello world, open brackets, close brackets, is an expression. It just returns the unit type or the empty return type. And if you were looking at it in an IDE that showed you the types, you would see this colon, open brackets, close brackets. So it's, again, a nice little concept to think about. And these expressions aren't necessarily simple expressions. They can span multiple lines. So here we've got a scope block where we're doing print line, and then we're returning 5 at the bottom. I tend to think of these scope blocks as like a function body with implicit return types. So it's like a mini function almost. So the curly brace to end curly brace was the expression, but the let y equal expression semicolon, that's a statement. Okay, we've got a question in the chat. The rules regarding semicolon and kind of scope brackets are confusing to me. No semicolon is required after curly brace. And is that correct? Depends on the context. So in this case, I have written let y equal something. That has to end with a semicolon because it needs to be a statement. A let can only be part of a statement like that. So as a result, that's why there's a semicolon there. If I had just written curly brace, print line, and then end curly brace, that would be acceptable to not end with a semicolon because there's no let statement there. In the same way that like, be a good example. Well, I guess actually it wouldn't compile if I didn't put a semicolon after the 5, because it would be trying to return a 5 to nowhere. Yeah, okay, great. Let's carry on and we will come on to structs briefly later. Okay, just want to mention comments. So as with all programming languages, well, most programming languages, Rust supports comments. These are the three most common ones that you will see. Most of them will be 2 slashes. That's what you use for almost all of the comments that you're writing in kind of everyday usage to yourself. The triple slash comments are what you see for documentation comments. These are the things that are read by tooling. They're what you use when you generate documentation from your code for if you're writing libraries. And you can put lots of really nice things in triple slash comments like Markdown, and then it will render properly. If you're working in an IDE like VS Code, if you've written a triple slash comment above your function, then wherever you call that function, you can hover over it and you'll get a little pop-up with the information from that doc. It also supports multi-line comments or these block comments. These are slightly less common, but can be really useful if you just want to quickly comment out a whole block. It's worth noting these are not the only types of comments that you will see, but they're by far the most common, and they're the only ones you probably need when you're starting out. Also want to talk a little bit about control flow. So you'll be familiar with hopefully with this kind of syntax. We've got if and else if. So if checks a condition. You'll notice, unlike C++, we don't need brackets here. You could put brackets in, but you don't need them, and it tends to be idiomatic not to include them. Yeah, but other than that, it's pretty normal. You have if, you have else if, and then you have else at the end. You do need the curly braces in all of these. We talked about expressions and statements. If blocks are expressions, and that means they can be assigned. But if you are assigning them, so here I've written let non-zero equal, that means that I need to have an else block on it so that it returns the same type. If it didn't return anything, then I wouldn't need an else block to return the same thing because the else block is kind of implicitly just returning the unit type. It's not doing anything. But in this case, I'm returning x, and x is a number. Therefore, I need to return a number, the same type in my else block. The next thing to talk about is loops. Just realized I forgot to add in an extra slide, so I'll see if I can quickly add that later and show you. But these are like the simplest loop, but also probably the ones that are the least common to see. But they again can be considered expressions. So in the top one, we're just looping forever, printing loop. In the second one, we've got a counter. We're looping and then we're breaking on some condition. You also have totally normal for loops, which I meant to include here, but did not after speaking to Melia. I totally forgot. But I can show an example of that after. It's kind of how you imagine in terms of the syntax, and there's lots of examples online, but it supports, yeah, for loops like you're hopefully used to. You can also, instead of doing for loops, you can use iterator patterns. So if you're coming from a more functional background, there's really nice support for iterators. When I do a break in a loop, that can return a value. So here with the let statement, it's going to assign after the break. So there's a question in the chat, why are we assigning to result? We are not using it anywhere. This is just a code snippet example. If you're not using it for anything, then you wouldn't assign to it. And if you did assign to it, if you did assign to it, but you didn't use it later, you would get a warning telling you had an unused variable, which is handy because the programming language agrees with you. Why are you assigning to it if you're not using it? Looking at going back to the kind of data types, there are more complex data types available to you. These can be user-defined or they can be defined in the standard library. The standard library is super rich, full of loads of types, but most of them are essentially just under the hood structs or enums. So here I've got a struct. This will hopefully look similar to what you've seen in other languages. So we've got named members here of the struct, ID and flag, and then the type on the right-hand side. For enums, these can be simple enums like you see here, but they can also have data in them, which is something that takes them a bit beyond what you might be used to if you're coming from like a C++ background. And you'll find those are really powerful and really, really common in Rust to have a lot of data in your enum variants. It's kind of, yeah, it's closer to a std variant almost, but with much easier to work with syntax. Actually, it's closer to a union, but with all the safety that you would expect from a strongly typed language. As mentioned, there are standard library types that are essentially under the hood, just structs or unions. I want to talk about three of the most kind of common collections, because if you go away and you start doing something fresh yourself, you're probably going to want to use these types. The first one I want to talk about was vec. So vec is a vector. A vector is your heap allocated expandable data structure that you can insert and extend entries to, and then pop them off. I'm not going to get into the kind of stack versus heap behavior. If you're coming from a language that doesn't force you to think about those things, I'd say with Rust you can get away without knowing too much about it, but it does become a hindrance later. So it is worth reading a little bit around how allocations work and the kind of the memory model around Rust. You also have strings, which are essentially just secret vectors, apart from they are always UTF-8 strings. So talked earlier about the char type, which was 4 bytes. Even if you were just writing a simple character like lowercase a or a capital B, those each one would still be taking up 4 bytes of memory. With UTF-8, if you're not familiar with UTF-8, it's basically a very efficient string storage format, which has a variable number of bytes depending on which character you're using. So in this case, the comma space world exclamation mark, each of those characters would only be taking up 1 byte, whereas that first character, the hand waving emoji, would be taking up 4 bytes, potentially. I don't know exactly how much that particular character takes up, but that means you have interesting rules around indexing and things like that, and that's the price you pay for having efficient storage of your strings. But if you've had to do annoying string manipulation in other languages, this might be music to your ears because it forces you to deal with the fact that strings are actually not simple. Forces you to deal with that right from the get-go. And then hash maps, they behave exactly how you might expect. You can construct a hash map and then you can insert keys and values into them. There are subtleties around usage of these. There's some nice functions that are really useful to get familiar with, but for now I think it's just nice to know that these exist and you can look up the doc for how to use them. We talked earlier about type inference. It's worth calling out that type inference is not magic. It figures out what the type is based on what you've written. So in this top example here, if I write let v equal vec new and then try and print it, it has no idea what that's a vector of, which means it can't analyze type. And for Rust, everything needs to have a type at compile time. You have to know what type it is. So here it says type annotations needed for vec. Type must be known at this point. You can fix that by giving it an explicit type. So that might look like this. So let v colon and then the type, which is a vec of U32. Those angle brackets are how you declare what the generic t inside the vector is. And then it's the same thing, vec new. But Rust is quite smart, so you might not run into this problem immediately. And the reason you might not is because it can infer the type based on the future uses of the variables. It can like work backwards. So in this case, because I'm pushing an I32 here, so I've written let mut v equal vec new, print line v dot push 42. That v dot push 42, I can only do that if v is an I32 already, which means that there is a vector of I32 already. So it can then figure out, it can trace back up the tree and say, okay, this v was supposed to be a vector of I32. And that's why in Rust code you won't see as many types as you might imagine littered through the code, even though it's a strongly typed language, because it will figure it out for you for lots of cases. But in the cases where it can't figure it out, it will force you to explicitly declare that type. The last thing I wanted to mention, which will again be covered more in the next chapter, but it's something that a lot of folks struggle with, is slice types. So I talked briefly about strings and briefly about vectors. Slice types are like views into it. So if you're coming from a C++ background, the closest thing would be like a string view, apart from without the fears of there being a dangling reference. In this case, on the first line here, let s equal string from quote hello. The quote hello end quote is a static string slice, and I'm then using that to create a heap allocated string. And then on the next line, I'm doing let len equal s dot len, which is on the string type. But then when I'm doing these slices, those are views into my heap allocated string, which I constructed from the static string, which was just existing in the kind of static memory of existing in the kind of the data bit of the binary. Yeah, and you can also do something similar for slicing into other data, which might not even be heap allocated, it might be stack allocated. So here I've got an array and I can get a slice into that array. So slices, it doesn't care where the memory is. It just needs to be a view onto some amount of data. Yeah, and you will see this syntax a lot. You'll get warnings if you are trying to take a parameter as like a reference to a vector, which I know we haven't talked about references yet, but if you start tinkering before next week, you might run into that. And yeah, this is what you're passing around instead, is a reference to some data somewhere. And that's the kind of slice type. Okay, that was end of part one. That was a whistle-stop tour of the first chapter. I'm sure I misspoke at various points and said things wrong. So yeah, do check out the kind of learning resources. There's the Rust book. There's also Brown University created this Rust book with quizzes so that you can go through the chapter and then you can get quizzed on the content of the chapter. I haven't done it myself because it didn't exist when I was going through the Rust book originally, but apparently it's very good. And then there's the docs themselves. There's a bunch of resources that I haven't put in on this slide that we'll add for previous ones, but you'll hear people talk about Rust, for example, Rustlings. Oh yeah, someone's mentioned Rustlings in the chat. And yeah, there's loads of good resources. But for now, while we've got the floor, we can try and answer some questions now for the first few chapters.
So I have one question. In the previous slide, there was an assert, and there were two arguments that were being compared.
Mhm.
The last one. So slice is a slice of the array, like A. And what is this right parameter? It's a slice of what? Uh,
So the slice parameter here is like instead of a like ref str, it would be like ref to an I32 slice.
no, no, okay. So what does this assert do? Like,
Oh, so this assert is basically it will terminate your program if these two things aren't equal. So this is something you might include in tests, or you might include just while you're tinkering around to figure out how stuff's working.
correct.
So,
So the left side I understand, but I'm not able to understand what's the value or what will be the value of the right side of
oh,
that
I
assert.
see. Okay, so where it says ref open square brackets 2,
Yes,
3.
ref 2 comma 3,
Yeah,
but it's not being associated either with slice variable or with A.
yeah.
So
So yeah, it's not associated with variable A. What that is a static slice. So in the same way that I was mentioning how on the first line, the kind of double quotes, hello and double quotes is like a static. So I've just kind of written the value and then that value will be stored somewhere. That's similar to the kind of this syntax here with the kind of open square brackets, close square
so
brackets.
this so this
It's like a
static is
reference to
coming.
the array that can then be kind of viewed as
Oh,
a string type.
okay. So it's so the value of this is still coming from A only, right? So it's more like comparing the slice with the uh, another slice of A and seeing that both are equal or not. Is it
Yeah, and
something
it's
like
checking
this?
the values of the items in this comparison. It's not checking that it's like equal in memory.
Right, right. Okay. Okay, yeah, that's interesting because the strange part is that I don't see any association of the right side with A, but it's still getting it from A. It's linking to A in that sense.
The left-hand side where it says slice, that is looking into A. The right-hand side is not associated with A at all. It just happens to have the same values. And the only reason the ref is there is so that it's the same type, so that you're comparing a slice of I32s to a slice of I32s.
Okay, now I understood. I think you're right. So 2 and 3 are just the values, and
Yeah.
we are providing and or reference because we want the type also to be same. Otherwise, it will complain for type mismatch.
Exactly. Yeah. And I
Oh,
put this
okay.
slide in here kind of as like bonus content because it's slightly beyond the scope of these chapters, but you tend to come across slice types quite early on and people get confused. So I think it's good to introduce it early, but we'll talk about it in more detail in future chapters.
Perfect, perfect.
And
Thank
that
you
kind
so
of
much.
dot dot syntax is, yeah, it's like reading the data. So for like let slice, I take this top one here, it's saying, okay, this here is my string. I'm going from index 3 up to the end, which is the length here.
Okay,
And in this case, it's similar. I'm going from 1 up to 3, and this is going from 3 all the way up until the end. So these two are doing exactly the same thing.
makes sense, makes sense. Yeah, thank you so much.
No problem.
Yes, there have been two other questions in the chat. One is what exactly is a view, and I think it goes in the same direction here.
Yeah, so Vue, it's a C++ concept that I was kind of throwing in for C++ developers. You won't really hear it kind of mentioned, I think, too much in the Rust world. When I say view, I tend to mean it's like you're looking at some other data that exists somewhere else. But a slice, that's also always true for. So in this case, it's I'm looking into a slice of some other data, but I'm not looking at the full data. So I guess a good way to think of it is like if I'm passing around a vector, I need to know where I start at the vector and the length of the vector. And then I need to know, like, I need to be able to add data onto the end. So that needs to be the end. Whereas with a slice, I don't need to know whether or not I'm at the start of the vector or whether or not I'm at the end of the vector because I can't insert values into it. It's not a variably sized thing. It's just like a look into some other data somewhere that I'm not looking after. It's probably a terrible description. I maybe shouldn't have included this without um, having the full slides to back it up for context. Um,
But I think especially if you come from the C++ background with modern C++, Vue is helping quite a lot here. Yeah.
yeah.
And the other question was about recommendation, where to start, if the book is the best starting point or if you have any more tips.
I really like the Rust book, but also that's how I started. What I would advise is like looking around at resources, and if you find yourself getting stuck on something, just search for that concept and see if you can find additional resources, and whichever ones chime with you, those are probably the ones to look for. I know there's a textbook that some people really like, but I'm drawing a total blank on the name. Might be the O'Reilly one. Um, if anyone knows which book I'm talking about, then let me know. But yeah, have a look 'cause there's some good textbooks out there. But what's nice about the Rust book is it's completely free. It's very easy to get started, and lots of people will have read it, so it's all kind of familiar concepts. Um, okay, got a few more questions in the chat about will this course cover async/concurrency? No. So this kind of 4-part probably won't get to that. That said, we have covered async and concurrency a fair bit. So I can drop recordings in the chat of previous meetups on it. We could also potentially do some additional refresher sessions. Maybe we add a section 5 on async and concurrency because it is something that people trip up on a lot. But in order to get the most out of that, you kind of need to have the fundamentals kind of nailed. Another question was, are we planning to read any new or reread any Rust book? Definitely open to suggestions on which books people would find useful to go through. When we run a book club, we generally get volunteers from the members of the meetup to lead chapters, which has worked really well in the past. So if there's a book that you would not only be like to see covered, but would also be willing to lead a chapter on, that's yeah, just let us know in Discord. Or I can put another poll out. I think we've done that in the past for book club suggestions. We did Rust for Rustations last year, but we never actually completed it. We had the summary chapter still to do. So maybe we'll do like an abridged version of the Rust for Rustations book club. And then we'll be able to do a summary chapter at the end to actually finally complete it. Someone's mentioned about the exercise on exorcism. Yeah, people really like, especially if you're quite like a practical learner and you'll find it easy to start writing the code, then going with something like exorcism can be really useful. Zero to production Rust. Yeah, I have read that one. It is good. It's quite specific, I would say, and it's a lot of library use. But if it's the domain that you're planning on working in, then it's got a lot of really useful stuff in it. So we could absolutely do a zero to production book club. I think it's been through a few iterations since I read it as well, so it's probably moved on a fair bit. Yeah, and I think hopefully, like after this kind of initial 4 chapters, it will make other learning resources much more accessible because you'll have the kind of fundamentals down, and then it'll open up like a wealth of learning resources to you. Has anyone had any trouble setting up their Rust environment or had any questions about how to do the kind of initial setup to get to the point of being able to tinker? I'm going to take the silence as either meaning that the setup went super smoothly or that people haven't done their setup. Oh, someone said setup is super easy. Yeah, completely agree. They've done a really good job on the setup instructions.
Yeah, no, the same. Just use the text editor and the command line following the book for the setup. That went quite well. But I think I'll switch to VS Code and just try and get a bit more used to that.
Nice. Yeah, VS Code is works really well, especially seeing the type annotations, I think is really helpful when you're starting out to know what you're actually dealing with. And it's very, very useful. The debugging experience isn't amazing, but you rarely have to debug because if it compiles, it normally works, which is nice. Okay, but question, do you recommend reading the Nomicon after finishing the Rust book? And by extension, do you use much unsafe in your day job? I tend to only really use unsafe in the context of FFI, so foreign function interface. I don't tend to have too much of a use case beyond that. That said, I would love to do a Nomicon book club. So I think we can learn about unsafe Rust even if we're not using it in our day job, I would say. So I'd definitely be up for that. It'll be slightly beyond the scope of this introduction to Rust course, but it'll definitely be a worthwhile learning experience.
Maybe to add to that, unsafe Rust is really rarely needed. But if you go in a direction, if you really want to get out most of the performance, or you have like memory constraints, and you have to implement something like a variable size type. So, for example, where node, like there's a continuous memory on the heap where you have like a dynamic sized string on it and so on, but everything continuously at one side on the heap. That's where you really need these unsafe concepts. Or for FFI, I think the FFI parts are there are quite a lot of resources about that. So if that's if interest for you, then how do you pronounce it? Nomicon, Rusty Nomicon is a very good source.
I think what's nice about learning about unsafe Rust, even if you're not writing it, is it helps you to kind of understand the kind of assumptions that your code makes all the time, that with unsafe you can suddenly like violate, and then it becomes your responsibility as the developer to uphold those assumptions is the right word, not prerequisites. But just behavior. Like there's certain things that in Rust is like it says this is how a well-formed Rust program should behave. And if you violate that, like if you're coming from like a C and C++ background, there's a lot more things you can do that in Rust you just wouldn't be allowed to do. Like you could do it with unsafe Rust, but you would be, if you're violating some behavior that Rust assumes, then it's kind of all bets are off in terms of what your compiled output will be. So like undefined behavior is the enemy, which you should never encounter if you're dealing with safe Rust.
And maybe what we could add, I think in the Rust and Atomics book club, we had quite some usage of unsafe Rust to learn about concurrency. So I think it's on YouTube too, right?
Definitely. Yes, like the main, whoops. Stop sharing. Let me just get the links for our YouTube channel. So we did a book club on Mara Boss's book, Atomics and Locks, which is just one of my favorite technical books of all time. I think it's really well written. And we did a book club going through the chapters, which goes through in chapter 1, it kind of does a serious whistle-stop tour of all of kind of the basic primitives. And then the later chapters are going more into detail about how atomics work. And I'd say at that point, it becomes fairly language agnostic. So if you're coming from a C++ background and you're just looking to learn about atomics in the context, in any context, then I'd say it's still very useful. But it obviously does talk about them specifically in the context of Rust, but it's using the C++ data model. Oh, thanks, Tim. Chat already. Great. And then in terms of talks on async we've done before, so we did an introduction to async in Rust. Which is there. We also did, I think I mentioned just now, chapter 1 of the book club. I think these are both ones that I led, but there are other chapters that other folks have led as well. But I seem to just love taking the async chapters. So yeah, those are both ones I've done. We also, we did a full book club of the Rust book itself in its iteration as it was at the time, which was, gosh, 4 years ago. So it shouldn't have moved on a huge amount. But if you are reading ahead and you're wanting someone else's take on a chapter, then you can have a look and see when we went through those chapters 4 years ago. But yeah, I think there's kind of like this first section, like the difference between expressions and statements is really useful to get your head around when you're thinking about like, do I need a semicolon here? What is this returning? So I think it's worth, if that bit didn't make sense, just have a play around writing little short dummy Rust programs, seeing what compiles, reading the error, and thinking to yourself, like, is this an expression or is this a statement? Does this return anything? I think, yeah, and as mentioned, like I didn't include a for loop. I did intend to on someone's recommendation, and then I forgot to add it. So you can look up the syntax for loops and hopefully they're straightforward. But if there's any confusion, then you can ask questions in the Discord, which I will repost the link for. Any more questions before we wrap up for the evening? Hopefully that was useful and the pacing was okay. As I mentioned, like there's loads of resources online. The Rust book covers everything that I've covered here. So if anything didn't make sense, you can reread it there. There's a lot of additional information in there as well that I didn't cover. But you can also just post questions in the chat. And yeah, have fun.